Welcome to Sports Science. Today we'll be exploring 3 of Newton's laws using the soccer ball. We'll be starting off with Newton's first law. It states that an object in motion will stay in motion
unless acted upon by an outside force. This law is also known as the law of inertia. And as we pass the ball,
you can tell how an object at rest stays at rest unless acted upon by another unbalanced force.
In this case, the foot also serves as a brake. This law also explains how goalies work, as they have to stop the ball and exert an outside force on it.
Okay, let's move on to Newton's second law. This is a law that states that force equals mass times acceleration. How can we see this on the soccer field? Well, when a player is a little heavier than another, he runs slower because he needs more force in order to gain more acceleration.
I can move faster because I'm lighter. I can't hit the ball as hard as a heavier man.
Let's focus on Newton's third and final law of motion. It states that for every action, there is an equal and opposite reaction. How do we see this on the soccer field? For example, let's say we're fighting for the ball and we both hit each other as hard as we can. As you could see, both players were exerting force towards each other and bouncing off of each other. For instance, where Newton's third law can be observed on the soccer field. What did we observe? We saw that when the player kicked the ball and the ball reached the net, it automatically bounced back. That's because the ball carried force, and when it crashed against the net, it had an opposite reaction, which was to bounce back because the force the ball carried was traveled back to it when it hit the net.
The third law is also reflected through the crossbar. When you strike the ball, it carries a force, and the crossbar exerts it back.
You know, Christian, I seem to know all of Newton's laws by heart, but I still seem to suck on the soccer field.
Show me.
I know what the problem is. Don't worry, Javier. With physics, we can help you. What you have to do is hit the side of the ball, and then physics takes care of it.
Could you show me?
Yeah. By kicking the side of the ball, you will hit the top corner, and then you'll get better.
Never thought about it that way, man. I just realized that if I hit the ball with more force, it will travel farther. And if I hit it with less force, it'll travel less. The same way, it will dip if I hit it soft, as it'll travel in a straight line when I hit it really hard.
You should give it a try.
Okay. I'm improving, but I still need a little more work.
I can help you, Javier. Remember when hitting the ball, that we're talking about a vector. We need more than force, direction too. And with your foot near the ball, you can have support and direction.
Oh, so it's like a vector. We need to hit with force and direction.
Yes, let's give it a try.
Now I'm getting really better. I'm gonna make sure this vector goes into the top thing.
Nice work, Javier.
We've got it. Let's apply all the laws together. Let's interchange passes with different strength and direction.
All right.
Stop.
Thank you for joining us on this episode of Sports Science. We'll catch up with you next week when we work on the basketball issue.
Third law is also reflected when you hit the post.
Okay, this is also exemplified when the ball hits the crossbar.
This is also exemplified when the ball bounces off the crossbar.
Newton's third law is also exemplified when the ball.
Law is also exemplified when the ball bounces off of the crossbar.
Newton's third law is also exemplified when the ball bounces off the crossbar.
Off of the crossbar.
Hits a crossbar.